Hello, am I audible? Hello, Ruchita, can you confirm if I'm audible or not? Please, anyone?
Yes, ma'am, you're audible.
Okay. We'll wait for 2 minutes so that if anyone wants to join, then we'll start.
Okay, ma'am.
Uh, am I audible now? Can anyone confirm if I'm audible or not? Okay. So hello everyone. Welcome to the live discussion session of waste to energy conversion, instructed by Professor P. Mondal from IIT Roorkee. I am one of the TA for this course. My name is Asma Parveen. I am a PhD scholar in Civil Engineering Department at IIT Kanpur. I'll be taking 2-hour discussion session on every Sunday from 7 to 9 p.m. I encourage every one of you to please join. And if you have any problem or if you want to discuss anything, you can discuss with me. I'll try my best to help you. And also you can share your questions on the discussion forum on the portal. So first, the session is of 2 hours. So I'll start by giving a brief introduction of what was taught previous week, and then we will try to solve the previous year assignment questions, which will help you to solve the present assignment questions. So can I start now? Okay.
Yes.
So one more thing, if there is any issue related to video or slides or audio, you can just message me or you can stop me in between and just you tell me.
Okay.
Okay. Okay. So I will start with the last week's lectures. So first, is my slide visible?
Yes.
So we'll do a brief summary of last week material. So sir started with what is waste, what are the types of waste, and how we can classify each waste. So first, there was a classification for solid waste. We can classify solid waste on various classification like usability, what are the sources, what is the combustible nature of the waste, whether waste is biodegradable or not. So on the basis of source, if the waste is coming from municipality, like our household, then it is categorized under municipal solid waste. If it is coming from industries, then it is industrial, and if it is coming from agriculture, then it is agro-based. So this is the composition of municipal solid waste in India. Like you can see from the right figure that it is the composition of municipal solid waste in India. And the left one, I have taken it from EPA website, which shows the composition of municipal waste generated in US in the year 2018. So I want to ask one thing. Can anyone just figure out what is the difference in the composition between the two countries? Anyone?
Biodegradable waste.
Yes. The content of biodegradable waste in India is much higher as compared to US. Also, the portion of recyclables is way less in our country as compared to US. Can anyone want to tell why this is the case in that there is difference in composition between India and US?
Because in India there is agricultural waste more, agricultural and food related waste.
But I have compared the municipal solid waste. Agricultural waste is not included in this.
So maybe because of food waste.
But what is the reason for this? Anyone?
Ma'am, it may be due to segregation at source.
It is the reason. In foreign countries and developed countries, the waste is segregated by the user itself. But in our country, it is segregated by the municipal workers.
Yeah.
But the main reason is the prosperity. Like we are developing nation. That's why we don't have that much income that we can, like, prime importance of our is to get the food. Then there is a tendency after getting the required food and all things, then people try to live prosperous life. But in US, they have lots of prosperity. Apart from like food, they will try to purchase packed items, not in bulk items. So that will contribute to recyclable waste. There will be lots of furnitures, metals and all. That's why there is a huge difference in composition between developing and developed nation. Am I clear? Also, there is a trend that with prosperity, there is an increase in the municipal solid waste generation. First, I would like to describe what is municipal solid waste generation. Like how much it is the difference between the municipal solid waste produced and from this amount, whatever recyclable is recycled, that is minus. Like I have produced 1 kg of waste and I am recycling half kg, then generation will be 1 minus half, that is 0.5 kg. So there is so municipal solid waste generation is very high in developed nation as compared to developing nation. The reason for this is, I'm so sorry. So the reason for this is the informal sector of recycling is that is very much established in developing country like India. In India, we don't have any formal sector to recycle the waste. We have the kabadiwalas who come and collect the waste and it is recycled by the users. But in developed nation, manpower is very costly. So everything is mechanized and is done by vehicles. So the portion their wastewater generated is much as compared to our developing nation. Okay. So there is also a trend that with increase in prosperity, municipal solid waste generated will increase, but there will come a time when it will be peak and then it will start to decline. For like our country, there is an increase in municipal solid waste generation. So it will reach peak and then it will reduce. The reason for this is that in our country, presently we have informal sector for recycling. Slowly, our country's income level will increase. So prosperity will increase and no one wants to do the job for kabadiwala. It's very difficult job to do. If anyone is getting more money, then that person will try to do some better job. So with increase in prosperity, this informal sector will start to decline. And for establishing a formal sector for recycling, it will take time. So our municipal solid waste generation will increase. With time, it will reach a peak and then decline. But there is one solution for this. What we can do is, like, if we strengthen our recycling system along with generation in waste, then there is a chance that our generation will be reduced. If production of municipal waste is increasing and we are making our recycling sector more profound, then there is chance that municipal solid waste generation will decrease. So, am I clear? Is anyone having any doubt?
So,
No.
ma'am, what will be the peak level?
I don't have the figure. Sorry?
Which we can expect in our India. What could be the peak level, as you told earlier?
Okay. I don't have the figures, but I will share it next time.
Sure. Yeah.
Okay.
Okay.
So after discussing the solid waste, there was a discussion on wastewater. Like solid waste, depending on the source, it is classified. Also, the wastewater is classified depending on the source. If it is coming from household, then it will be municipal wastewater. If it is coming from industries, then it will be industrial, and like that. Also, the composition of the municipal wastewater will depend much more from where it is coming, what for the water is being used. So we'll discuss about the composition and characteristics on the later slides. Then route for solid waste management. In India, earlier the waste collection system was not that strong. Simply the waste was collected without segregation and it was dumped in any nearby river or in an unengineered way on the landfill. But now, fortunately, we have a segregation of waste at the source. Like waste is collected from the household and it is segregated in that locality only, and then it is transported to for further and then it is transported to the further facilities to handle the waste. Okay, we'll move forward. So, need for the production of energy from waste. What is the need? Can anyone tell me? Why we need to extract energy from the waste?
Yeah, because day by day energy requirement is increasing, and generating energy from waste will help us in both ways. That it will reduce the waste also, and we will get energy also.
Okay, very good. So the prime focus is sustainable development. Can anyone tell me what is sustainable development?
Sustainable means which will cover three parameters. It should be environmentally clean, economically feasible or viable, and there should be socially it should be equitable.
Yeah.
So all sectors of the society should get the benefit of the sustainability.
Yes. So in simple words, sustainable development is meeting the needs of the present without compromising the need for the future generation. Like we cannot stop developing. We have to develop, we have to become more, we have to develop economically, but without hampering our environment and the social values of people. So this is sustainable. We need to develop sustainably. And one more thing, one student Aryan told that we need to reduce the waste. If we are extracting from energy, like it is getting energy from secondary sources. Our cycle is one way. If we will make a circular economy, like we are extracting the thing from our waste, we are reusing it, then we are also reducing a lot of virgin raw materials to be used in our industries. It is like told by Aryan, it is like to benefit by two sides. So there is obviously risk associated with, because we are handling waste, we have to check what is the toxicity, how we are handling it properly, whether it is economically feasible or not. So next is characterization of solid waste. It is characterized in two parameters, physical and chemical. In physical characteristics, we have density, particle size distribution, hydraulic conductivity, and moisture content. Sorry. So there was three types of density: envelope, apparent, and true. Can anyone tell me what is the difference between these three? Anyone? You have the figure. So, what happens in bulk density? We take the overall volume of the material, including the voids in the particle, as well as the interparticle spaces between the particle. And in apparent volume, we take the volume of voids in the particle, but we exclude the interparticle distance, interparticle spaces between particle. Like we can see from B that we have included the we have excluded the white portion. These are the interparticle spaces, but we have included the volume for the voids. But for true density, what we take is only the volume of the solid. We exclude the interparticle spaces as well as the void space. Am I clear?
Yeah, ma'am.
So if anyone have any doubt, you can type in the chat or you can stop me in between. Now the chemical properties of solid waste. It was explained in the second lecture, I guess, that it is proximate analysis, ultimate analysis, fusing point of ash, lignocellulosic composition, and leaching properties. And finally, the main objective of the course is energy extraction. We can find the energy value from the heating value. It was well explained that we can find the how much energy value from the bomb calorimetric experiment.
Ma'am,
Next.
what is the exact significance of the density so far waste to energy is concerned?
Like
Why it is
I will try to explain. Like if we have food waste, it is bulky in nature,
right?
Isn't it? Because it has lots of moisture content. But if we take paper, newspaper, they are not bulky. They are recyclable and their density is very less. So one of the role of density in waste management is like compaction. If the waste is very bulky like food waste, we cannot compact it. But if the waste is like plastic, newspaper, paper, we can use compactors for compacting it.
Right.
Okay. Also, if the like food waste is bulky, we cannot extract energy by conversion of food waste because it will take lots of energy to remove the moisture from it, isn't it?
Yeah.
But
No.
like, sorry.
My question is that suppose we'll compare two waste materials.
Okay.
One is gobar,
Mm-hmm.
powder, and another one is green grass.
Green grass.
Grass is having the low density
as
compared to this dung.
Gobar. Yes.
Gobar. But heating value, if you compare the heating value from the energy point of view, the heating value of gobar is much more. So, how it is important to consider the density?
Energy, we can determine the energy value from the carbon content. Like in gobar, we have lots of organics present, but which is easily consumed by microorganisms. Like we use gobar to produce either digest it anaerobically to produce methane or we compost it. And microorganisms can easily feed on these. But if we compare grass, it is also compostable, but it has lots of complex organic matter like cellulose, lignocellulose, which is not easily consumed by microorganisms. It takes some time.
Right.
So this is, we can say in these terms. Also, I will see about your question and I will give you better explanation next time because I think this is the reason. Also, we use grass trimmings and all are very essential in composting for covering the compost and all we will learn in the later lectures.
No, this particular question is in my mind only because there are certain specific grasses now which is known as the energy grass, like super napier or that barley or lucerne. These grasses are specifically grown or cultivated for energy production.
Okay. Sir, I'm actually not aware of this, but definitely I will try. I will read about it and come to you on next time.
Okay, no problem, ma'am. Thank you.
Um, Now, characterization of wastewater, like solid waste, municipal solid waste, we can characterize wastewater on physical, chemical, and biological terms. In physical characterization, we have solid content, that is total solid, total dissolved solid, and total suspended solids, temperature, taste, odor, color. And for chemical analysis, we have hardness, BOD, biochemical oxygen demand, chemical oxygen demand, nutrients, which is mainly basically nitrogen and phosphorus, then heavy metals, salts, various inorganic compounds, and TOC, that is total organic carbon and dissolved oxygen. There was a explanation for the test for BOD, COD, and DO. You can refer from the lectures. And for wastewater, biological analysis is important because there may be pathogens present in water which are very harmful for humans and other living beings. So we need to do the biological analysis also of the wastewater also. So in our country, there is a huge problem of wastewater because what happens that 80 more than 80 almost more than 60% of our waste is just dumped is just discharged on the surface water bodies, and it contaminates the surface water bodies and even percolates in the groundwater system. So there is a huge demand that we manage our wastewater properly to make our rivers, lakes, groundwater, ocean less polluted. So, okay. Anyone have any question?
No, ma'am.
No, ma'am.
Okay. So we will start with the previous year, last year assignment questions. I want participation from you all. Okay. We'll start with first question. ICPMS stands for. Anyone? Anyone of you can unmute yourself, or you can type on in the chat box.
Integrated carbon plasma mass spectrometry.
No. I have got one answer. So someone asked me, what is kabadi wala? Track pickers. It is asked by Lionel Judah. Lionel? Is he? Okay. So ICPMS is inductively coupled plasma mass spectrometry. It is used to detect we can detect almost all metals present in periodic table using ICPMS. Next, sorry. It is a very straightforward question. Which one is non-biodegradable?
Glass.
Glass. Next is moisture and ash content of a municipal solid waste is determined by. Do one thing, you all type your answers in the chat box so I can see that who are participating. So we'll wait for 1 minute so that everyone give the answer. I got 5 answers and there are 8 participants. Okay, if you don't know answer, whatever you think is correct, just type in the chat box. I got one more. Okay. So the correct answer is proximate analysis. Next is bacterial infection in living system cannot be directly induced from. Just type your answers in the chat box.
Actually, I had one question.
Yeah.
Ma'am, from NPTEL, the mail has came that the registration for the exam is now available.
Mhm.
So I wanted to just ask that the exam will be of MCQ based or the theory based.
Oh, actually, I'm not sure about this. You can mail the NPTEL team about your query.
Okay, ma'am.
So I got the answers. It is noise pollution because we come in contact with air, water, soil, but noise is only we can sense it. This is a numerical. Determine the stoichiometric air required to combust methane. I will give 5 minutes to solve this question. Those who have Those who have solved, you can just type your answers in the chat box.
Lokal kasadang kurtao. Shark fish.
Ma'am, you are mute.
Definitely, I will give the solution. I'm telling you all to just try once.
Excuse me, ma'am.
Yes.
Actually, I haven't attended the last 3 weeks lectures, ma'am. So if I attend it, I will be able to solve this problem, right?
Yes.
Okay. I just registered last week, so I don't know whether how to finish this 3 weeks portions.
Yeah, this is from week 1.
Okay, ma'am. I haven't went through it. I'll just go through it.
You go through the lectures.
Okay. Thank you.
So I got 2 answers. That is D. Obviously, answer D is correct. Anyone is solving? Like I will wait for 1 minute more.
Ma'am, you are on mute.
Sorry. Please try once. Because I got only 2 answers. Like, is there anyone who is trying to solve this? I can wait for 2 minutes more. No one is trying? Okay, I'll tell you how to solve it. So basically, it is a question based on simple calculation, which will be based on how to write the chemical reaction. Like we are burning methane, anything is burned in presence of oxygen. So for combusting methane, we need oxygen, and oxygen is present in air. And you can, there is one thing to note, that the question has asked us to find the air requirement, not the oxygen. So we will consider the composition of air. So air consists of 21% oxygen and 20.9 it is oxygen, 78 point some percent of nitrogen, and the rest is other gases. So we will assume that it is composed of 21% oxygen and 79% nitrogen by volume. This is the composition of air by volume. So for combusting methane, we require oxygen, but air is composed of nitrogen. Although nitrogen will not take part in the reaction, but still it is present. So we have to consider that. So one statement I have written is this, that each mole of oxygen is each mole of oxygen is accompanied by 3.72 moles of nitrogen. You people are getting this statement or having problem in understanding why it is 3.76 moles of nitrogen? If anyone have any doubt, you can ask me.
Ma'am, can you repeat it once more?
I'm asking that I have written that each mole of oxygen is accompanied by 3.76 moles of nitrogen. So you all are getting it? It is simple universal law of gas. PV is equal to nRT. So I'll explain you. It is there is the PV equals to nRT. So R is constant, isn't it? If T and pressure are constant, that is for given temperature and pressure, there is a relationship between volume and number of moles. That it is if for a given pressure and temperature, number of moles is equal to volume. So from this concept, we can we have 21% composition of oxygen and 79% composition of nitrogen by volume. So we have volume, we can calculate that how many number of moles of will be of oxygen and nitrogen directly from this relation, that volume is equals to number of moles, isn't it?
Yes, ma'am.
Anyone have still doubt like how we are getting this? Anyone, if you have any doubt, you can ask me, or you can type in the chat box. So I consider that no one have any doubt in this. So we calculated how many moles of oxygen and nitrogen is present in the air. And for burning methane from normal balancing of this reaction. So anyone is having doubt in how to balance this reaction? Someone is talking. Balancing is clear to all you all? Please reply. Anyone? Okay. Rojita type yes. Yes, yes. So balancing is clear. It is a very simple reaction to balance. Like for 1 mole of methane, we requires 2 moles of oxygen, and each mole of oxygen is accompanied by 3.76 moles of nitrogen. So we will have 2 into 3.76 moles of nitrogen, which will give carbon dioxide, water, and nitrogen, because it will not be consumed in the combustion. So it is simple stoichiometry, like 1 mole of methane will require 2 mole of oxygen. That is 16 grams of methane requires 2 into 32 grams of oxygen, and 7.52, it is equal to 2 into 3.76 into 2, because nitrogen mass is 40, but nitrogen gas is N2, so we will multiply by 2 into 14 grams of nitrogen. So we'll calculate for 1 gram of methane, how much grams of oxygen will be required. It will be sum of 2 into 32 grams of oxygen plus this grams of nitrogen divided by mass of methane, which will be 17.16 gram air per gram of methane. Clear? Anyone have still doubt on this in this question, like how to solve this? It is clear to everyone? Okay. Okay, we'll move to next question. This is, which route has relatively slower rate of energy production from waste? Waste we consider here is biomass and municipal solid waste. Answers in the chat box, please. Please type your answers in the chat box. Like, Am I audible? Can anyone confirm if, yeah. So you can type your answers in the chat box, which option is correct. B. Okay. 3 people have typed their answers. I'll give you 30 seconds more. I got 1, 2, 3 answers. Okay, the correct answer is A, biological routes. Those are type B, it is thermochemical route. It is fast as compared to biological routes because we are providing extra energy. It is thermochemical. We are giving energy for the chemical reaction to take place. So it will be much faster than the biological routes. Biological routes are slower as compared to chemical and thermochemical because there is capacity of every microorganisms to take or produce the energy. Like if you take any strain of methane producing microorganisms, so they will have a particular inherent capacity to produce or consume organics and produce methane. There are technologies to get more energy from them, but since they are performed mainly by microorganisms, they are much slower than thermochemical and chemical routes. Am I clear? Like those who have typed given answer to be B. Okay, we'll move forward. Okay. So it is a very straightforward question. During heating value calculation of a waste material, HHV and GCV termed are used. HHV and GCV stands for answers in the chat box. Please everyone try to participate. If you don't know the answer, just type whatever you feel like it's correct. I have just got one answer, one more. One more. I'll wait for 30 seconds more. We have 10 participants and I only got 1, 2, 3, 4 answers. Everyone just write the answer in the chat box. A. So you all are right. Answer is A. This high heating value and gross calorific value. So next question. From the following flow diagram, identify the process. Like we are putting the waste, there is a reactor with endothermic reaction, like we are giving energy, some source of heat, and we are getting product in the form of liquid, gas, and some charcoal, that is solid. So which of these three process or none of these is this picture depicting? So I got pyrolysis. Yes, answer is pyrolysis. A, very good. We'll wait for 30 seconds more. So the correct answer is pyrolysis. Can anyone tell me the difference between pyrolysis, gasification, and incineration? Anyone? Like what is pyrolysis, gasification, and what is incineration?
Pyrolysis is a endothermic reaction in the absence of oxygen or the low oxygen limit
Sorry,
environment.
can you repeat?
Yeah, sure, ma'am.
Sure.
The pyrolysis is an endothermic reaction. We giving some energy to get the fuel, liquid, gas, and char in the absence of oxygen.
Absence of oxygen.
Gasification is a
Mhm.
yes, ma'am.
Okay,
The
proceed.
limiting of on the absence of oxygen.
Sorry, Prabhakar, there is a lot of disturbance in the background. I can't hear you very clearly. Please repeat.
Yes, now is audible, ma'am.
No, your voice is breaking. Like you can
Okay.
type in the chat box. Anyone else?
Pyrolysis happens in the absence of air.
Yeah, proceed. Yeah, Lennon. So what is gasification? Anyone?
Partial oxidation of a substance.
Okay, and what is incineration? Burning method. Anyone? What is incineration? Yes, incineration is exothermic. The measured Lionel,
Incineration is burning
yeah.
of hazardous material
Proceed, please.
at high temperature. Burning
Okay.
of hazardous material at high
Mhm.
temperature is incineration.
Okay. And gasification?
Gasification, no idea.
Ruchita is correct. Like in incineration, the temperature is high, but pyrolysis gasification also temperature is high. So the highest temperature is for incineration, then it is for gasification, and the lowest is for pyrolysis. But the major difference is oxygen. In pyrolysis, there is no oxygen. We apply the heat externally through some source, and we burn the gas and we burn the waste. In gasification, we give partial oxygen. If like for burning 1 gram of some waste, we need 10 grams of oxygen, but we will not provide 10 grams, we will provide lesser oxygen. And for incineration, it is a complete combustion in which we provide sufficient amount of oxygen to combust the waste. So the end product of the waste will depend on which process is being used. If we are using incineration, no doubt the flue gas which we'll get will have very high temperature, and we can use that gas for energy extraction, for running the turbine and generating the energy. And the end product of gasification is syngas, which is basically composed of carbon dioxide, hydrogen, and we can burn that gas further to get energy. And in gasification, we also get some solid residue. But in pyrolysis, we get all the three phases. Like there will be syngas, there will be char, and there will be liquid also. Am I clear? One more thing I want to add is like incineration, like any
Which
burning
is the
process.
most
Sorry.
common used method, ma'am? Which is the most common used method?
So for most common use, I think is incineration. But the method which we will use will depend on what the end product we want to get. Like if I want to get the end product to be char, then I will use pyrolysis. But if we want the end product to be to run the turbines, then I will use incineration.
Okay.
Also, the method will depend upon what is the composition of the waste which is to be burned.
Okay. Thank you.
Okay. Next is what chemical reaction makes biodiesel? You can write your answers in the chat box. So I got one answer. I need more participation. Please type your answers in the chat box. So you all are correct. Answer is A, transesterification. In transesterification, the fat in the oil is converted to biodiesel. Sublimation is the process in which a compound is converted directly from the solid to the gaseous phase, not to the liquid, directly from solid to the gaseous phase. And polymerization is the process in which monomers are interconnected through each other through links to form the polymers. And fermentation is the one in which, in anaerobic conditions, microorganisms feed and give the end product to be the alcohol or acid. Basically, the higher organic compound like glucose, sugar, it is converted to simpler ones in fermentation. Fermentation is also used for making in brewery industry and also for preserving of food for a longer period of time. So this is the last question of assignment 0. Waste can be classified on the basis of, write your answers in the chat box. I need more answers. Just type your answer in the chat box, please. Only 3 people have like answered. Like four people have given the answer. I request everyone to just type the answer in the chat box, please. Okay. The correct answer is D, that is all of these. On the basis of source, solid waste can be classified as from where it is coming, whether it is used in industry or municipality or something else. On the basis of compostability, it will be compostable or not. On the basis of combustibility, it will be combustible or non-combustible. On the basis of biodegradability, it will be biodegradable or non-biodegradable. So answer will be all of these. So we will move to next assignment. Assignment 1. So the first question is, the desirable characteristic of solid waste for higher energy production is, you have carbon content, hydrogen content, heating value, or all of the above. Just try to answer in the chat box.
Hello, ma'am. This assignment is related to week one lecture.
Yes, the assignment is related to week 1 lecture.
But they is showing which of first question is which of the following is not a quality.
No, the questions I am discussing are previous year questions.
Okay, that is previous year question.
Yeah, the assignment question which I am discussing is previous year questions. Your assignment question will be different, but these are being
Okay.
discussed to give you the how you will approach the questions.
Okay, ma'am. Okay, ma'am. Okay, thanks. Yes.
So just no one has typed the answer. Okay.
Value? Sorry.
Yes, the answer is D, all of the above. Like if there will be more carbon content, then we will get more energy. If it will be more hydrogen content, then it will burn and produce water, H2O, we will get energy. If the heating value is also high, then we will get more energy. So answer is D, all of the above. Next question is gasification and pyrolysis process for energy production from biomass and waste are associated with. Just type your answer, sorry, in the chat box. Okay, the answer is A, thermochemical. Energy is used. External energy is applied for gasification and pyrolysis for the chemical reaction to takes place. So the answer is thermochemical conversion. Next question is which of the following density exclude the volume of pores and interparticle spaces? Just type your answers in the chat box. I need more answers. Only 2 people have responded. I need one more answer. Okay. The answer is C. But 2% have typed this as apparent. No, the answer is C, absolute density. So, initially, I have discussed it. Sorry. Like in apparent density, we do consider the volume of pores. We exclude the interparticle spaces, but we consider the volume of pores. And in envelope or bulk density, we consider both volume of pores and interparticle spaces. But in absolute density, we do not consider volume of pore, nor we consider interparticle spaces. We only consider the volume of solid. So answer is C. And in bulk density, we consider these volume of pores as well as interparticle spaces. Am I clear? So we'll move forward. So next question is identify the apparatus in the figure given below. Just type your answers in the chat box. I need more answers. One more, please. Please type your answers in the chat box. So the answer is B. It is a sieve analyzer. Next question is find out the missing steps in the following depiction of ultimate analysis. Like there is sample gas and carrier sample, carrier gas, combustion, then mixing, then detection. You have to determine what is A and what is B. Just write your answers in the chat box. Please write your answers in the chat box. I got only 2 answers. So answer is B. In ultimate analysis, that is CHNS analyzer, we find the carbon, hydrogen, nitrogen, and sulfur contained. We first burn the material, then there is reduction, followed by mixing, and then there is separation of these elements, and finally it is detected. So answer is B. Those who are not getting the correct answer, I will just tell you to just go back to the lecture, just watch it once again, and if still you have doubts, you can ask a doubt in the live session or in the discussion forum. So we'll move forward to next question. It is also from ultimate analysis, like from ultimate analysis of coal, determine its trace content. I just now have given you the answer while explaining the previous one. So I want everyone to write the answer in the chat box. Till now I haven't got any answer. So please write the answer in the chat box. Just write option A, B, C, or D. I need 2 more answers. Why you're not writing the answer? See, I need active participation from you all. Till now I haven't got the correct answer. So I'll wait for 1 minute more. No. Let's wait for 1 more minute. C is also not correct. No, B is not correct. Only A and D is left. A. Yeah, the correct answer is carbon, hydrogen, nitrogen, and sulfur. Through ultimate analysis, we determine carbon, hydrogen, nitrogen, and sulfur. And ash and volatile, we determine it through proximate analysis. I request you all to once again go through the lecture. You will find there that proximate analysis is used to find the volatile matter and ash content. But ultimate analysis is used to determine carbon, hydrogen, nitrogen, and sulfur. Am I clear? Yes. Okay. Let's move forward to the next question. So it is a pretty straightforward. In proximate analysis, moisture percent is measured by, if I can't see. In proximate analysis, moisture percent is measured by drying the sample at dash for 24 hours. So you have to tell me what is the temperature, whether it is 90 degrees centigrade, 80 degree, 105 degree, or 120 degrees centigrade. I need more answers. Only one student has typed the answer. Definitely the answer is C, 105 degrees centigrade. It is a direct question from the slides. Next question, it is also a direct question, like Winkler's method is used for the measurement of dash. pH, conductivity, dissolved oxygen, none of these. Just write your answer in the chat box. I'll wait for 30 seconds more. So the answer is C, dissolve oxygen. It is a direct question from the slide. So we'll move forward. So I will like to ask you one question. Like DO measurement is used for measuring one more parameter of wastewater. Can anyone tell me what is that parameter?
I'm not getting, ma'am. What is it?
I'm asking you, like we need DO measurements for determining one more parameter of wastewater.
Okay.
What is that parameter? Like DO is used to determine that parameter, initial DO and then final DO. So I got one answer. Yes, BOD. It is biochemical oxygen demand, for which we determine the initial DO present in the sample, and then we incubate it for 5 days, and then we find the final DO, and through the calculation we determine how much is the biochemical oxygen demand of the sample. Good. So we'll move to next question. Like, which analytical instrument is used for the measurement of trace metals in solution? It is atomic absorption spectrophotometer, turbidity meter, pH meter, or conductivity meter. Just write your answers in the chat box. I'll wait for 30 seconds more. Please just type your answer. Yes, the answer is A, AAS. See the first question which we discussed, that is ICP-MS. What is the full form of ICP-MS? That is through that also we can detect the trace metal. And that instrument is much more sensitive. Like the concentration which we can measure through ICP-MS is much less than what we can measure from AS. Yes. Right? I'm clear? Just anyone got the point which I was telling? Anyone confirm whether if you didn't get? So I'll repeat what I'm telling, that through ICP-MS we measure metals, and from AAS we also measure metal. So the concentration which we can measure through ICP-MS is far lesser than what we can measure from AAS. Like we can measure in micrograms per liter in ICP-MS, but in AAS the sensitivity is not that high. Understood? Anyone please confirm? So the answer is A. This is the last question of assignment 1. It is a numerical type. So first I will read the question and I will give you 7 minutes because it is a very big question. Like it is very, the question is very simple, but the language is like it's very lengthy. A solid waste with 1% sulfur is combusted in bomb calorimeter. The temperature of the bucket water increases from 26 to 28 degrees centigrade. The water equivalent of the calorimeter is 2402 calorie per degree centigrade. 1 gram sample is used for the test and PAR 45C10 wire is used for the ignition. Out of the 100 centimeter wire, 2.6 centimeter is used. To titrate the calorimeter washing for 24.2 ml of 0.0709 normal sodium carbonate is required. Calculate the gross heating value of the waste. Consider the thermometers are working perfectly. So it is a question, one example was also given based on this concept. I will give you what is the formula to be used and what are these terms T, W, E1, E2, E3, M. I will give you all. You just have to put the values and find the answer. I will give you 7 minutes for this. Please try to solve it. Those who have not gone through the lecture, they can also solve because I have given the full concept. What are the formula you will use? What are these terms? So please try to solve this question. Those who have solved, you just try to answer in the chat box. I got only one answer, so we'll wait for 2 more minutes. Is anyone still trying to solve it? So I got 2 answers, 2 more person, Ruchita and some Prithvi Ranjan.
No, I did not submit it, ma'am.
Okay. Are you trying to solve it?
Ma'am, actually, I don't know. I am trying, but I am unable to solve these questions.
Okay. Right. So should I wait for 2 more minutes for you to solve it?
No, ma'am. I can, but just I'm reading the question and watching the some solution. What are you giving? But I'm unable to solve it. Yeah.
Okay. So there are 4 past participants and one is given answer C and 2 other as B. But the correct answer is C, 4749.09 calories per gram. Leonin and Prithvi Ranjan, do you want 2 more minutes to just see and cross check whether you have done any calculation mistake or anything else? Okay. Okay, then I will go for the solution. So it is a question from the lecture. Our example was also solved that we can find the gross heating value by using the formula Hg is the gross heating value is T minus T into W. T is the net corrected temperature, that is the rise in the temperature. Here the rise is from 26 to 28. So there is rise of 2 degrees centigrade. So T is here 2. W is the energy equivalent of calorimeter in calories per degree centigrade. W is already given. So it is given in the terms of water equivalent of calorimeter. That is 2402 calories. Wait. See. Changes initial temperature is 26. Final is 28. So there is change of 2 degrees centigrades. And W is already given. Energy equivalent is 2402 calories per degree centigrade. And even E2, E3, even is the correction for heat of formation of nitric acid in calories. It is calculated from the how much ml of sodium carbonate required for titrating. So C1 is milligrams of standard alkali solution used in acid titration. So we have given it is 24.2 ml of this normal sodium carbonate is used. So C1 is 24.2. Here C1 is 24.2. So even is equals to C1. So directly we are getting E1 from C1, that is 24.2 calories. Now we will do for E1. Sorry. Now we'll go for E2. E2 is correction in calories for heat of formation of sulfuric acid. It is given as 13.7 into C2 into M, where C2 is the sulfur content in percentage. It is given in the first line that it is 1% sulfur is combusted. The sulfur content in solid waste is 1%. So here C2 will be 1. So E2 will be 13.7 into 1 into M. M is the mass of sample in grams. So it is also written, you can see my annotate like 1 gram sample is used for the test. So mass is also given, it is 1 gram. So E2 will be 13.7 into 1% of sulfur into 1 gram of solid waste. So E2 will be 13.7 calories. Now we'll see for C3. For E3, it is correction in calories for heat of combustion of fuse wire. Here we are using PAR 45C10 wire, and there is reduction from 10 centimeter to 2.6 centimeter. So 10 minus 2.6 centimeter is the wire used. So E3 is given as 2.3 into C3. C3 is centimeters of fused wire consumed in wiring. So E3 will be 2.3 into 7.4. 7.4 is 10 minus 2.6 centimeter, it is 7.4. And we will get E3 as 17.02 calories. So we will put all these in the formula, like TA, that is 2 into W is 2402 minus E1, E2, E3 divided by mass of the waste. We will get 4749.08. Okay. If you want to confirm those who are getting answer B, you can just, I'm giving you 2 minutes to just resolve the question.
Yes, ma'am. I have miscalculated C2. C1
C2.
and yeah.
Okay. E1 and E3 was correct?
Yes.
Okay. So you need time to check or should I proceed further?
No, ma'am, you can proceed. I
Okay.
guess C2 is pretty simple, actually.
Okay.
I'm
It is totally, this question is very simple. The thing is, you should remember what is E1, E2, E3. This
yeah.
is the, this is, if you know what is E1, E2, E3 and you have calculated it, then you will get correct value for gross heating value. Okay. One more thing I want to know from you, like we are getting 2 hours on Sunday from 7 to 9 p.m. Do you want me to discuss the questions of previous year, or I should also go with the material for the lecture? Like I should start with discussing some of the things discussed in the class, and then I should go for questions.
Yes, ma'am, that will be better.
Okay. Ruchita and Prithvirajan and Arun, you can also tell me. Sure, we will next, this time also I tried to give you a recap. So next time I will continue like this. I will give a brief recap and then we will solve the previous year questions. And since we have a lot of time, I will also add some more questions from my side and then we will solve in the live session. But
Yes,
I
ma'am.
need participation from you all. And I will encourage you to please join the session on Sunday as well as on Saturday. We will be discussing the questions.
Ma'am, Saturday and Sunday both are, is it a repeat or?
Same material will be covered, but from 2 different years.
Okay,
Okay.
all right.
But
Ma'am,
maybe yes.
ma'am, Saturday timing is 3 to 5, right?
Yes, Saturday timing is 3 to 5 p.m. and on Sunday it is from 7 to 9 p.m. Also, I want to add one more thing that we are different years, so maybe the question may be different. So please join both the session.
Okay.
Okay, ma'am.
So I have added one question. It is based on also stoichiometry. Like air contains nearly 20% oxygen by volume. It is already given that it is 20% by volume. So the volume of air needed for complete conversion of 100 ml acetylene, that is C2H2, will be. It is a simple question. You just have to calculate how much volume will be needed. It is based on the previous question which I have discussed in first assignment for methane. Please try to solve it. I will give you 5 minutes to solve this question. But please try to solve it. If you are getting a wrong answer, then no problem. After solving, just write your answer in the chat box. Arun and Ruchita, are you trying to solve it? Should I wait for some more
Yes.
time? Okay, I'll wait. Ruchita, are you still trying?
Yes.
I'll wait for 2 more minutes for you.
Okay.
So sorry.
Your voice was not audible, ma'am.
Okay. Sorry.
Now I am able to.
I got it. So we will start by writing the stoichiometric reaction for acetylene to convert it to carbon dioxide and water. So we can see from balancing this reaction is that 2 moles of acetylene is required. For 2 moles of acetylene, 5 moles of oxygen is required. So we need to calculate the volume, isn't it? So we will go back to the universal gas law, that is PV equals to nRT. Here the conditions are not given, so we will calculate the volume at STP. After putting pressure at 1 atm, R at 0.081 and temperature at 0 degrees centigrade, after converting it to Kelvin, it will be 273. We will get for 1 mole of gas, the volume is 22.4 liters. If you want to, you can check by putting the values. So from this, we will get that for 1 mole of gas at STP, the volume is 22.4 liters. So 1 mole of acetylene will be equals to 22.4 liters into 1000, that is 22400 ml. So 100 for we have to calculate what is the volume needed for 100 ml. So for 100 ml of acetylene, we require this much. So 100 ml of acetylene is equals to 100 upon this is this much mole. Okay. So from we know that for 2 moles acetylene, we require 5 moles of oxygen. For this much of acetylene, we will just use linearly calculate how much moles of oxygen will be required. So we got the moles, and we know at STP the volume is 22.4 liters. We will multiply by volume, and we will get the how much ml of oxygen will be required. Am I clear? Okay, Ruchita, you got it? How to approach this question?
Yes, ma'am. I got it. I can do it. Yeah.
So we will use the composition given in the question. It is 20% by volume. We have calculated the volume of oxygen required. So we will calculate like if we take 100 out of 100 ml, 20 ml is oxygen. So we will calculate for 250 ml of oxygen how much ml of air will be required, and it will be 1250 ml. So this is for today. Like this is the last question. I will be taking the session on next Sunday from 7 to 9 p.m. only. So I will encourage you to please join. We will discuss at the start. I will give you a brief recap of the week 2. Then we can go through the questions, and we will solve the question based on the material for week 2. So that's all for today. Thank you so much. Thank you so much for joining.
Thank you so much, ma'am. Thank you.